Today on Sci Guys, liquid viscosities. Welcome to Sci Guys, I'm Ryan.
And I'm Adam. On today's episode, we're going to be measuring liquid viscosity by having a race.
And I'm going to win.
But not you and me, the liquids. Viscosity is the rate at which like particles in a fluid will flow past each other. A fluid with a high viscosity will flow slowly, while a fluid with a low viscosity will flow quickly.
The ingredients you're going to need for this episode includes maple syrup,
Coffee cream,
corn syrup,
olive oil,
honey,
lamp oil,
rubbing alcohol,
canola oil,
and dish soap. The equipment you're going to need for this experiment includes 2 pans, 1 deep to catch your liquids, and 1 long and shallow to pour your liquids down,
a piece of paper,
tape,
a ruler,
a pen,
some small dishes or shot glasses,
and some saran wrap.
Although we're not dealing with anything dangerous today, it's a good idea to wear an apron or a lab coat and goggles to protect against spills and splashes.
The first step in your experiment is to take your piece of paper, your ruler, and your pen, and mark out a line at about 25 centimeters down your paper from one of the edges. Connect the 2 dots that you just drew to make a finish line, and your paper should be ready to go. Now take your paper and your shallow cookie tray, and on the back of it, tape it down with your tape so it's nice and flat on the back of the cookie tray. Once you have it down and taped, use a pair of scissors and trim off any excess paper. The next step is to cover our paper and our shallow cookie tray in plastic wrap. Take your tape and securely tape down all sides of your plastic wrap to prevent any water or other liquids from getting your paper wet.
Now we measure out equal proportions of our ingredients into our little containers.
In the first heat of our race, we have water, rubbing alcohol, and cream. Water finishes first with a time of 0.233 seconds, and rubbing alcohol finishes last with a time of 0.4 seconds. In the second heat of our race, we're going to be racing olive oil, lamp oil, and vegetable oil. Lamp oil finished first with a time of 0.467, and olive oil finished last with a time of 0.633 seconds. In the final heat of our race, we're going to be racing honey, maple syrup, corn syrup, and dish soap. First across the finish line is maple syrup with a time of 1.33 seconds, followed by the blue dish soap with a time of 4.633 seconds. And then slowly but surely the great corn syrup crosses the line with a 19.5 seconds, and then finally honey with a 20.767 seconds. Here are the results of our race. Water crossed the finish line first, meaning that it has the highest flow rate and the lowest viscosity. Honey was last across the finish line, meaning it has the lowest flow rate and highest viscosity. Let's look at this experiment a little closer. All substances are made of tiny particles called molecules, and if you remember from our electrolysis of water video, water has around this many molecules of H2O in every 8-ounce cup. All molecules have a force that keeps them around other molecules of the same type. This force is known as cohesive force or cohesion. Cohesive forces are strong in solids and weak in gases. In a liquid, these forces are strong enough to keep the particles close together, but weak enough that they are allowed to slide past each other, giving liquids the ability to take on the shape of their container. But how do cohesive forces affect viscosity? Viscosity is the measure of how easily particles of the same type in a fluid are able to flow past each other. Or in other words, how strongly a fluid's cohesive forces will affect the movement of its molecules. Viscosity can be measured by calculating a fluid's flow rate. In liquids like honey or maple syrup, particles have a high cohesive force, making it hard for the molecules to slide past each other easily, giving the liquid a high viscosity and a low flow rate. When it comes to liquids like water or rubbing alcohol, the cohesive forces are very weak, which allows the particles to slide past each other easily, giving the liquid a low viscosity and a high flow rate. Viscosity can be affected by temperature. When we heat a liquid like honey, the molecules gain energy, move further apart, and the cohesive forces between the honey molecules becomes weaker, decreasing viscosity and increasing its flow rate. On the other hand, if we cool honey, The particles lose energy to the outside environment, move closer together, and the forces between the honey molecules become stronger, increasing its viscosity and decreasing its flow rate.
Well, that was liquid viscosity raises. I hope you enjoyed it.
If you enjoyed this episode, let us know in the comments below and subscribe for future episodes.
Make sure to like us on Facebook and follow us on Twitter.
And if you have any questions related to this episode or about science, just let us know on Facebook or down below. We'll try to help you as best possible. Thanks for watching. Bye.
Bye. Where were you?
I won. Here at Sci Guys, we're always curious how experiments turn out. So if you do these experiments at home, share a video or photo of them with us on our Facebook or Google Plus page. But remember to always ask your parents' permission before you share any photos or videos.